Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on high calorific value and low calorific value of fuel. So what is the meaning of fuel? During burning process in the presence of oxygen, it produces heat energy. So fuel is a combustible substance. So this process is called the burning of fuel in the presence of oxygen. So this process is called combustion. So in this mainly we discussed about calorific value. Today's session is calculations, determination of high calorific value and low calorific value of fuel. So first we discussed about what is fuel, and after that we'll discuss about calorific value. So fuel is a combustible substance. During burning process in the presence of oxygen, it produces heat energy. It is called fuel. So your calorific value, so mainly the efficiency of fuel. So it can be understood by its calorific value. So if calorific value increases means it is considered as good fuel. So your calorific value means how much amount of heat energy liberated. Total amount of heat liberated when a unit mass of fuel is burning. Completely burning. Unit mass means here 1 kg, 1 gram or 1 part. So 1 unit mass of fuel burning completely. In this case, how much amount of heat liberated? That is called calorific value of fuel. So the efficiency of fuel, it can be easily understood by its calorific value. If this value increases means the coal or fuel considered as good fuel. So there are two types of calorific values, high calorific value and low calorific value. So high calorific value, it is also called as gross calorific value. So how can I define this high calorific value or gross calorific value? So during burning, or for example here, how much it is defined as the total amount of heat liberated. Total amount of heat liberated or heat produced when a unit quantity of the fuel is completely burning. When a unit mass of fuel burning, in this case how much amount of heat liberated. And the combustion products are cooled at room temperature. The combustion products are cooled at room temperature. So that is called high calorific value. So how much amount of heat liberated when a unit mass of fuel is completely burning, and the combustion products are cooled at room temperature. So in this case it evolved latent heat. That heat also we can consider in this gross calorific value or high calorific value. So here HCV equals heat liberated plus latent heat of vaporization of water formed. Latent heat of vaporization of water formed. So for example, usually hydrogen present in fuel. So during burning process in the presence of oxygen, it produces combustion products. So in this case, it liberates heat. That is called heat liberated. And also we can consider combustion products are cooled at room temperature. So that means here, for example, hydrogen present in fuel during burning process in the presence of oxygen, it produces heat energy. And also combustion products are cooled at room temperature. That means hydrogen reacts with oxygen, then produces water. So the steam combustion product cooled at room temperature. So in this case it evolved latent heat. Thus the latent heat of condensation of steam is evolved. It is also included in this gross calorific value. So what is the meaning of lower calorific value or net calorific value? So total amount of heat liberated when a unit mass of fuel is completely burning in the presence of oxygen is called lower calorific value or net calorific value. Here we considered only during burning process how much amount of heat liberated. We cannot consider any latent heat or combustion products cooled at room temperature. So that evolved temperature we cannot consider here, only net amount of heat liberated when a unit mass of fuel is burning. That is called lower calorific value. So LCV equal HCV minus latent heat of vaporization of water produced. Latent heat of vaporization of water produced. So here LCV equal HCV minus mass of hydrogen into 9 into latent heat of vaporization of water. So here for example, hydrogen during burning in the presence of oxygen, it produces water. So it one part, for example, 1 part by weight of hydrogen, it produces 9 part by weight of water. 1 part by weight of hydrogen, it produces 9 parts by weight of water. So here it produces, in this case it gives a latent heat of steam is 587 calories per gram. 587 calorie per gram latent heat is evolved. Theoretically it is proved that. So here LCV equal, how can you calculate this one? HCV minus mass of hydrogen into 9 into latent heat of vaporization of water formed. How can you calculate NCV, lower calorific value? So NCV equal lower calorific value means how much amount of heat liberated when a unit mass of fuel burning. Only we consider that energy only, heat energy only. We cannot consider latent heat of vaporized water. So its value is NCV equal GCV minus 9 by 100 H into 587. Here hydrogen means percentage of hydrogen present in fuel. Percentage of hydrogen present in fuel. And 587 is the latent heat of vaporization of water. Latent heat of vaporization of water formed. So these two formulas are most important for numerical purpose for calculation of high calorific value and low calorific value. So given by Dulong's. So Dulong's formula for the theoretical calculation of calorific value. So according to that, GCV, gross calorific value, or HCV, high calorific value, it's equal 1 by 100 into 8080 carbon and 34,500 H minus O by 8 plus 2240 sulfur kilocalorie per kg or calorie per grams. So here carbon, hydrogen, oxygen, sulfur, these elements present in this fuel. So in this formula, these carbon, hydrogen, oxygen, sulfur represents the percentage of corresponding elements in the fuel. And it is based on assumption that the calorific values of carbon, hydrogen, oxygen, carbon, hydrogen and sulfur are found to be 8080, 34,500 and 2,240 kilocalories when 1 kg of fuel burning, completely burning. These are the calorific values of carbon, hydrogen and sulfur. So here all the oxygen in the fuel is assumed to be present in the combination with hydrogen in the ratio. So always during burning process, if hydrogen reacts with oxygen or if in case oxygen present in fuel or in the form of H2O, steam, the combination form. So what is the ratio of hydrogen and oxygen? 1:8 by weight. 1:8. So the surface hydrogen available for the combustion is H minus O by 8. H minus O by 8. So here NCV or LCV, it's equal HCV minus 9 by 100 H into 587 kilocalorie per kg. Here H is the percentage of hydrogen present in coal or fuel and 587 is the latent heat of vaporized water formed. So by using these two formulas, gross calorific value and net calorific value, we can calculate the HCV and LCV of fuel. These two are most important for numerical purpose for calculation of HCV and NCV. Now see the problem based on this HCV and LCV. So first one is calculate the gross and net. Calculate the gross and net calorific values of a cold sample having the following composition. So that is carbon percentage is 80% and hydrogen is the 7% and oxygen 3, sulfur 3.5%, nitrogen 2% and ash is 5%. So these elements present in this given this in this percentage given in this formula. So how can we calculate the gross calorific value and net calorific value? So what is the formula used for this purpose? For calculation of gross calorific value and net calorific value. So here GCV equal formula is 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur. So these are the assumption of calorific values of carbon, hydrogen, sulfur. So here carbon, hydrogen, oxygen, sulfur, that elements indicates how much percentage present in this fuel. You are given this sample. So given this form here in this problem, given that carbon percentage is 80 and hydrogen percentage is 7, oxygen percentage is 3 and sulfur percentage is 3.5. So all these values substituted in this above equation, and here nitrogen also present in this, but nitrogen doesn't have any calorific value. So it is negligible. It is negligible. We cannot consider undesirable. Undesirable. Because if in case nitrogen present in fuel, nitrogen doesn't have any calorific value, so it reduces the calorific value. So always good fuel contains less percentage of nitrogen in fuel. So all these values of carbon, hydrogen, oxygen, sulfur substitute in this above formula. So finally you'll get 1 by 100 into 6,46,400 plus 2,28,562.5 plus 7,840 calorie per gram. So after calculation, next step is 1 by 100 into 8,82,802.5 calorie per gram. So finally, gross calorific value or high calorific value of fuel is in this problem 8,828.0.25 calories per gram. This is the gross calorific value of cold sample. Given cold sample. So now we'll calculate the net calorific value. Net calorific value. So how can we calculate the net calorific value? So NCV or LCV it's equal GCV minus, we can remove latent heat of combustion products cooled at room temperature. So we cannot consider the temperature. So in this case NCV equal GCV minus 9 into H by 100 into 587. Here 587 is the latent heat value. Latent heat value is 587 and here hydrogen is percentage of hydrogen present in cold sample. So in this problem it's given hydrogen percentage is 7%. So we can substitute that hydrogen percentage in this given formula, above formula, and we can substitute the gross calorific value also. So we could here GCV value is 8,828.0.25 minus 9 into hydrogen percentage is 7 by 100 into 587. So it's equal 8,828.0.25 025. 8,828.025 minus 369.81. 369.81. So it's equal 8,458.21 calories per gram. 8,458.21 calories per gram net calorific value of given cold sample of fuel. So in this problem, you can calculate the gross calorific value and net calorific value by using Dulong's formulas. So what is the gross calorific value of given fuel? 8,828.025 calories per gram. And net calorific value of given fuel is 8,458.21 calorie per gram. So next problem is a sample of coal contains in the following composition. So here carbon is 84% and hydrogen is 12, oxygen is 2% and sulfur is 1%. So and the remaining being ash. So calculate the gross and net calorific values of the fuel. So here how can we calculate the gross calorific value of fuel? By using this Dulong's formula of gas calorific value. So it's equal 1 by 100 into 8080 carbon plus 34,500 into H minus O by H plus 2240 sulfur calorie per gram. So substitute these percentages of carbon, hydrogen, oxygen, sulfur, whatever given in this formula, given in this problem, we can substitute in this above equation. So now we'll get next step is 1 by 100 into 6,78,720 after multiple with this 8,080 into multiple with 84. And we'll get 6,78,720 plus when titrate again when 34,500 into 12 minus 2 by 8. So we'll get 4,05,375 plus when we multiple with 2,240 into 1, we'll get same 2,240 calorie per gram. So next step is 1 by 100 into 10,86,335 calorie per gram. So finally, we'll get the gross calorific value of given coal sample. So what is the value? 10,863.35 calorie per gram. 10,863.35 calorie per gram gross calorific value of given fuel or given coal sample. And next we'll calculate the net calorific value. So what is the formula net calorific value? It's equal HCV minus 9 by 100 H into 587. Here H means percentage of the hydrogen present in coal sample. So its value given in this 12%. So we can substitute this hydrogen percentage in this formula and also you can substitute high calorific value. So high calorific value is just calculated. What is that? 10,683.35 minus 9 into hydrogen percentage present in this formula problem is 12. Hydrogen percentage present in this coal is 12 by 100 into 587. So already we know that 587 is the latent heat evolved, or latent heat of vaporization of water formed. So that's value is 587. So it's equals 10,863.35 minus 633.96. So it's equal 10,229.39 calories per gram. So in this problem we can calculate the gross calorific value and net calorific value by using Dulong's formula by giving chemical composition of carbon, hydrogen, oxygen, sulfur, etc. And here remaining ash also there in this, but it doesn't have any calorific value, so it is also undesirable. So that means good coal always contains less percentage of ash. We consider good coal. So gross calorific value of given coal sample is 10,863.35 calorie per gram and net calorific value of given coal sample is 10,229.39 calorie per gram. Calorie per gram. Next, one more problem based on this high calorific value and low calorific value. So here, calculate the net and gross calorific values of coal sample having following composition. So here in this coal sample, carbon percentage present in this is 82%. Carbon percentage in this coal sample is 82. And hydrogen percentage in this coal sample is 8%. 8%. And oxygen percentage is 5%. And nitrogen is 1.4%. And ash is 3.6% present in this given coal sample. So now you can calculate the net calorific value and gross calorific value. Net and gross calorific value of coal sample. So here, what is the formula of gross calorific value? GCV equal 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2240 sulfur calorie per gram. So here these values 8080, 34,500, 2240, these are the approximate values of calorific values of carbon, hydrogen, sulfur when 1 kg of fuel is burning. And here carbon, hydrogen, oxygen, sulfur, it is represented as how much percentage of these elements present in this coal sample, given coal sample. So in this formula, this carbon percentage is 82 and hydrogen is 80, oxygen is 5% and nitrogen is 1.54, but it doesn't containing any calorific value, it is undesirable, and ash is 3.6. So coal doesn't, this is also doesn't contain any calorific value. So these two are nitrogen and ash are undesirable. Undesirable because these two doesn't have any calorific value. That means it if in case it's present in this coal sample, it reduces the calorific value, not supports the burning. So always good coal contains less percentage of nitrogen and ash. So we can substitute the carbon, hydrogen, oxygen, sulfur percentage, whatever given in this problem, we can substitute in this above formula. So finally you'll get, next step is after 1 by 100 into 8080 into carbon percentage in this formula is 82 and plus 34,500 and hydrogen percentage is 8 minus oxygen percentage is 5 by 8 plus 2,240 and sulfur percentage is, okay, it's not there, so its value is 0, we can take 0. So next step is 1 by 100 into, after multiplication you'll get with carbon 6,62,560 plus 2,54,437.3 calorie per gram. So finally gross calorific value of given coal sample is 9,169.8 calorie per gram. And I'll calculate the net calorific value or lower calorific value. So what is the formula? Here net calorific value means we can consider only how much amount of heat liberated when a unit mass of fuel is burning. So here that in heat energy only we consider, we cannot consider any latent heat. During combustion of combustion products are cooled at room temperature, that heat is we cannot consider here. So what is the formula of NCV? It's equal HCV minus 9 into H by 100 into 587. So here GCV value just we calculated. What is that value? 9,169.8 minus 9 by 100 into, here hydrogen is percentage of hydrogen present in coal sample. Here it's given 8%. So we can substitute in this formula. So minus 9 by 100 into 8 into 587. Latent heat award is 587. So after calculation, we will get 8747.34 calorie per gram. This is the net calorific value of given coal sample. So in this problem, in this sample, coal sample, we can calculate the gross calorific value and net calorific value of coal sample by using Dulong's formula. In this way, you can calculate the HCV and LCV. And one more problem we'll discuss. It is based on the proximate analysis. So what is the use of proximate analysis? To fix the price and quality. To fix the price and quality of coal sample. So that purpose, what we have to analyze in this coal sample? Moisture content, volatile matter, ash content and fixed carbon. We can determine in that. So here in this already previous classes we discussed about what is proximate analysis, how can we analyze, how can we determine the percentage of moisture content, volatile matter, ash content and fixed carbon, and what is its significance. Already we discussed previous sessions. So now I'll discuss problems based on that proximate analysis and how can we determine the moisture content, volatile matter, ash content, fixed carbon given present in this coal sample. So here, what is the problem given here? A sample of coal was analyzed as follows. 0.9824 grams of an air-dried coal sample was weighed in silica crucible. So in silica crucible, what is the weight of the coal sample we are taking? 0.9824 grams of coal sample taken in crucible. So after heating for 1 hour, its maintaining temperature is 105 to 110 degrees centigrade. So the dry coal residue weighed, again weigh out that after heating. So what is the weight of the coal sample? 0.9668 grams. So what we observed in that? Loss in weight. So the loss in weight expressed as the percentage of moisture content present in coal sample. Next, after that, the residue was covered with a lid, vented lid, and then heated strongly for exactly 7 minutes at 950 degrees centigrade. So the residue weighed 0.7900 grams. So after heating also, we observe that what is that weight loss? Loss in weight expressed as the percentage of volatile matter present in coal sample. Next, the crucible was heated strongly in air until constant weight was obtained. So the last residue was found to weigh 0.1200 grams. So here also loss in weight expressed as the percentage of ash present in coal sample. Now calculate the proximate analysis of coal sample. Calculate the proximate analysis of coal sample. So, given from this data, according to data, what is the weight of coal sample? 0.9824. 0.9824 grams. Weight of coal sample. So, now we can calculate the moisture content. Here, we can calculate the moisture content. Percentage of moisture content present in coal sample. So how can we calculate the percentage of moisture content present in coal sample? So here weight of coal sample or weight of crucible after heating by weight of crucible before heating into 100. This is the formula used for the determination of moisture content present in coal sample. So starting weight of coal sample is 0.9824. After heating 1 hour at maintaining temperature range is 105 to 110 degrees centigrade. So what is the weight of coal sample? 0.9668. So what is the difference between that expressed as a weight of coal sample. Loss in weight expressed as the percentage of coal sample, moisture content present in coal sample. So we can substitute the values in this formula. Finally, we'll get this one. So that means here weight of crucible after heating. That means what is the difference you'll get here. So actual weight is at 0.9824 minus after heating weight of the coal sample is 0.9668 by weight of crucible before heating. Before heating 0.9824 into 100. So finally you get the percentage of moisture content present in coal sample, that is 1.66938 percentage of moisture content present in given coal sample. And next, determination of percentage of volatile matter. After computing this moisture content, the same coal sample crucible closed with lid, heating in electrical furnace. Here maintaining temperature range is 950 for 7 minutes. So here weight before heating weight of the coal sample is 0.9824 and after heating, that means difference between. So here in the second step same formula, but here percentage of volatile matter present in coal sample. Here weight of crucible after heating step 2. Before that step 1, in this step 2 by weight of crucible after heating into 100. So your weight of crucible after heating. So it's equal, after heating we'll get 0.96, in this step 2. This crucible is covered with lid, heating in electrical furnace for 7 minutes at 950 degrees centigrade. So in this case, the residue of weight is 0.7900. 0.7900. And here actual weight of coal sample is 0.9668. 0.9668 by total weight of coal sample. This is the difference between these two. And by total weight of coal sample, starting we are taking is 0.9824 into 100. So finally, you'll get the percentage of volatile matter present in coal sample is 17.996 percentage. 17.996 percentage. Now you can calculate the ash content present in coal sample. So here also, what is the formula? Percentage of ash present in coal sample. It's equal weight of coal sample after heating in step 3 by weight of crucible or weight of coal sample before heating. That means weight of coal sample taken before that into 100. So it's equal 0.1200. So the last residual found weight is 0.1200 minus actual weight is before that 0.9824 by total weight of here directly are taking because ash content. So what is that value? 0.1200 by actual weight of the coal sample is 0.9824 into 100. So here 12.214 percentage of the ash present in coal sample. So now we can determine the calculation of fixed carbon present in coal sample. So how can we determine the fixed carbon percentage in coal sample? So what is the formula we are using here? Percentage of fixed carbon. Percentage of fixed carbon. It's equal 100 minus percentage of moisture content. Percentage of moisture content plus percentage of volatile matter plus percentage of ash content present in coal sample. So your percentage of moisture content is it's equal to 1.66. Here 100 minus moisture content given in this 1.669 plus volatile matter already given here. So what is that? We can calculate second step 17.996 plus ash content is 12.214. 12.214. 4. So finally we'll get 100 minus after addition we'll get 31.879. 100 minus 31.879. So it's equal 68.13% present in this coal sample. 68.13% of fixed carbon present in coal sample. So good coal always contains less percentage of moisture content, volatile matter, ash content, but high percentage of fixed carbon, because this carbon increases the calorific value. So in this way you can calculate the percentage of moisture content, volatile matter, ash content, fixed carbon present in coal sample by using this proximate analysis. This helps to fix the price and quality of coal. In this way you can calculate this percentage present in coal sample. So in this session we learn about how can you calculate the high calorific value and low calorific value of coal sample, and also we'll learn about that how can you calculate the percentage of moisture content, volatile matter, ash content and fixed carbon present in coal sample. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.